So now that you've learned how to find the area for a given z-score, we're going to flip this around and we're going to talk about how to find a z-score when the area is the value that's actually given. Okay, so thus far we've been given the z-score, we found the area. Now what we're going to look at are situations where we are given the area. Right, so this is giving me an area to the left at 0.26. All right, now as far as what this is going to look like on a sketch, what you have to keep in mind is that when you look at areas under the standard normal curve, if you are below the mean of 0, then you're looking at an area less than half, okay? Because if you split this curve right down the middle, you'd have half on one side, half on the other. If you're looking at an area left that's above 0.5, then you're above the mean and you're looking at a positive z. So this area is less than 0.5, right? It's 0.26. So I am looking for a z-score, and again, I'm just kind of guessing where it would fall, but it would be below 0. And I'm looking for a z-score. I don't know it, so I can't label it, where I am given the area to its left. Okay, so notice the difference between this and the problems that we've been doing. The ones before, the z-score was there, but we need to find the area. Now the area is there, but we need to find the z-score. So in terms of using our table to do this, what we have to remember is that areas, okay, which is what we're given here, are found inside the table. So when you go to your table with an area, you don't look it up on the outer edges like we did with z. You look for that area inside the table. So what I like to do with my areas when they're given is go ahead and write them to 4 decimal places, because that's what I'm going to have to compare it against when I look inside my table. And then what you're going to do is get as close as you can to that area. You're probably not going to find the exact area, but you're going to get as close as you can. So the values go in order, all right? You just want to kind of follow your trend. You've got, 0.23, 0.24. I'm just going to keep going, 0.25, until I get to a point where basically I would cross 0.26. Okay, so notice if I were just following the trend here, I would get to 0.2578, and then it jumps to 0.2611. And so what I would notice there is what I want, 0.2600, is in between those two. So if it's not showing here, then the exact area is not present in my table. Now what I do in that case is I compare those two and I look at the one that gets the closest to what I'm looking for. 0.2611 is closer to 0.26 than 0.2578. If you're unsure, if you can't tell, then just subtract 0.26 and see which one has the smaller difference. But the one that has the closest area is the one that you want to go with. But then you have to remember, you're not finding an area, you're finding a z-score. And your z-scores are on the outer edges of your table. So find the closest area, then use the corresponding row to get the value to 1 decimal place. In this case, that's negative 0.6. Use the corresponding column to get the second decimal place, which in this case is a 4. So the z-score that has an area to its left of 0.26 is negative 0.64. All right, we're going to use a similar method when the area given is to the right, but we're going to have to change it to an area left before we can go to our table. All right, so in this case, I'm still given an area, but the area that I'm given is to the right. My table only looks at area to the left, so before we use our table, we're going to need to change this to an area left. And the way we change direction under our standard normal curve, or any normal curve, is just to take that area and subtract it from 1. So the z-score that has an area left of 0.32 is the same thing as the z-score that has an area right of 0.68. And because my table uses area left, that's the one that I'm going to go with here. All right, so in terms of my sketch, the area to its left is less than half. So it's going to be somewhere down here. It's going to be a negative z. And the area that was given, again, I'm mainly showing you this in case you're given the sketch instead of being given the information in words. The area given here was the area to the right of 0.68. Okay, so that's what the sketch would look like. Whether it's in words or on a graph, if the area given is to the right, I'm going to subtract it from 1, get the area to the left, and this is what I need to use to find z. And then I'm going to do the same thing that I just did. I'm going to look for an area of 0.3200 and get as close as I can. So following my trend, right, you've got some 0.29s, you've got 0.30, you've got 0.31, you come to 0.3192, and then it jumps to 0.3228. So again, what you're looking for is in between these two. That means the exact value is not present in your table. So you take the one that gets the closest to what you're looking for, which is 0.3200. That's going to be this 0.3192. And then you just have to remember you're looking for z. So once you find that closest area, you're not done. You will use the corresponding row to get z to 1 decimal place, negative 0.4, and the column will give you the 2nd decimal place. So the z-score with an area to its right of 0.68 is negative 0.47. All right, last thing we're going to look at here in terms of finding z-scores is what do we do when we're given an area in between? And this is commonly written as a middle percentage. So again, what this would look like in terms of a sketch, notice here it says find the z-scores. And when you're given an area in between or a middle percentage, you're always going to have one that's negative and you're going to have one that's positive. Now the area that you're given here is the area in between, right? In the middle of the curve. And this given area is 95%, which in decimal form would be 0.95. Now, again, the key thing for you to remember is if you're going to use your table, you must know an area to the left. So before I can take this to my table, I've got to figure out the area for just this region down here to the left of the negative z-score. And the way you convert from an area between to an area left, you subtract it from 1. That puts you in the tails. And then you divide it by 2. All right, if I do that here, I'm given an area left of 0.025. And that's what I need to look for inside my normal distribution table. All right, so area left is 0.025. I'm going to get as close as I can. And this is one of the few cases where you can actually find the exact area. Okay, area is 0.025. You want the z-score. So for that area, the row would give you negative 1.9 and the column would give you a 6. Now, when you're doing area between, your answer always contains 2 z-scores. You can't do a between and then just give one number as your answer. The nice thing is, because this curve is symmetric, once you find the area left and you get the negative z-score, you always know that your other z-score is just going to have a positive sign. And you see that in your sketch here as well. So the z-scores that have the middle 95% would be negative 1.96 and positive 1.96. Okay, so I want you to study those a little bit. If you need to rewind your video, go back and watch it again. And then I want you to try these 4 check your understanding problems on your own. So pause your video, pull out your table or access it from one of the homework problems, and walk through each one paying close attention to whether it's a given area left, right, or between. Find the corresponding z-scores, and once you've done that, come back, unpause the video, and check your work. All right, so what I want you to notice here is that for each one of these, the first thing I did is I made sure I had area left. If that's what I had, like 0.4522, then I just went to my table. I got as close as I could to 0.4522. This one actually had the exact in there. And then I read off the, oops, I think I read that wrong. Hold on, let me go back and look again. Sorry, it wasn't 0.4522, it was 0.4500. All right, for 0.4500, the 2 areas on either side are 0.4483 and 0.4522. The one that gets a little bit closer was 0.4483. And so the z-score, using the corresponding row and column, was negative 0.13. For each of the others, if it was an area right, I just made sure that I subtracted it from 1 before I started searching my table. And then I wanted to show you one more with an area between here. Again, all you do for between, subtract it from 1, divide it by 2. And then you go find the closest area in your table. For between, use both a negative and a positive. Now, I will mention to you here, just so there's no confusion, in this particular case with 0.05, there's another area that's equally close. It's 0.0495, and it yields a z-score of negative 1.65. That would be okay for this problem as well. All right, so just let me show you what I'm talking about there. If you start looking for an area in your table, like 0.05, and you run across this, all right, you'd go, well, those are equally close to 0.05, so I can't pick one over the other. In that case, either of the corresponding z-scores would be accepted. So negative 1.64 would be fine here. That's the one that I used. but negative 1.65 would also be accepted as well. All right, so I want you to do a little bit of practice, right? Use your table, see how you do kind of working through these. And then I want you to come back and check out the last few videos, which are going to give you some options for using technology in place of the table. You can actually use the ALEKS calculator, you can use Excel, or you can use the graphing calculator in place of that table if you're having trouble making sure that you get the correct information when you go to your standard normal table.